Okay, so now what we are going to do is we are going to discuss about Boltzmann equation and Saha equation. Right? Now see, Boltzmann equation basically tells you, suppose let me talk about one particular case, 35 chlorine. Now if we look into the energy levels of 35 chlorine, so this is ground state, this is first excited state, this is second excited state. Okay, so and so on and so forth. Now suppose consider a box. This is a 3D box inside which only 35 chlorine atoms are there and nothing else. Okay, now let me slowly increase the temperature of this entire box. Then you might ask me, sir, how many 35 chlorine atoms are in first excited state with respect to those of ground state? Because I am slowly increasing the temperature, right? So what will happen? As the temperature is being increased, more and more collisions will be there, and if the thermal energy becomes equal to the gap, then the 35 chlorine atom will be getting excited to first excited state. Suppose the temperature increases even more, then the gap, if the gap matches that one, then it goes to second excited state and so on and so forth. This is basic idea. Now, so the answer to this question is, how many of them are in fourth excited state with respect to that of ground state at a particular temperature? And the answer will be given by the Boltzmann equation. Okay, this one is clear? Fine. Now, let us look into this scenario. Slowly the temperature keeps on increasing. Let us do this. But what will happen after that? What will happen is this. First, as I have told you, the atom will be ground state, then slowly more and more will be getting excited and so on and so forth. Right? Now, it will happen last excited state. What will happen after that? If the energy is more than that, ionization, right? Now 35 chlorine has how many electrons? 17. Z equal to 17. 17 electrons, right? So the moment it reaches the energy greater than the ionizing energy, what will happen? What will happen is the following. First, you only have 35 chlorine atoms. Then in this axis temperature keeps on increasing. So next what will happen? 35 chlorine will be there along with 35 chlorine 1 plus ions and electron also. Right? Then again temperature keeps on increasing. What will happen? Now we are slowly going to have a family of 35 chlorine. So first only 35 chlorine, next 35 plus 35 1 plus. And after that we will have 35 chlorine, then 35 chlorine, 1 plus, then 35 chlorine, 2 plus, and again 1 electron, 2 electron, and so on and so forth. And so the process will continue. Up to what level? Up to this point, when we have the entire family, full family. And what is that? When we will have 35 chlorine, 17 plus. Okay? But this will require a very large temperature. You can calculate it, in fact. This will require a very large temperature. Okay? And this is just from slowly increasing the temperature of the box and nothing else. Okay? Now, next question. So, when we were considering only the scenario where there was no ionization and you were asking me, sir, how many of them were in first excited state, how many second and so on, Boltzmann equation came to the rescue. Now what? Now we have got a much bigger family. So if you ask me, sir, look at this part, at this particular temperature, how many of them were in, how many of 35 chlorine 1 plus were there with respect to neutral 35 chlorine atoms? This is a very valid question, is it not? So, if we ask ourselves this question, then how are we going to answer it? Boltzmann equation will not help you. because here we are talking about ionization. Okay, so as I was saying previously, when we have only 35 chlorine atoms, then you asked me, sir, how many 35 chlorine atoms were there in first excited state, second excited state, even at this room temperature? Then at that time only the Boltzmann equation will help us to find this. Okay, now as the temperature keeps on increasing, the family becomes bigger and bigger. Now you might ask me, sir, how many 35 chlorine 1 plus were there with respect to neutral 35 chlorine atoms? Okay, this is also a very valid question. So how are you going to find it? This time remember, Boltzmann equation will not help you. Boltzmann equation will help me if I consider only the excited state of this part, right? But if I consider these two family members, ions, with respect to neutral, even here, how many of them are here with respect to this, how many of them are there with respect to this, and so on and so forth. If you ask me that, then only Saha equation will help you. So look at the Saha equation. This is the number of ions in the I plus 1 state with respect to I. For here, for our 35 chlorine, I can vary from, you see, 1 to 17 we have, right? And so you see, look into the structure of these two equations. Here Ni by Nj is just proportional to this exponential term and nothing else, right? But look at here, what is happening. Here Ni plus 1 by Ni, this stuff, that means the relative states of ionization, they depend again on an exponential term. This is quite similar. I am now comparing the structure of these two equations. So this is there along with the partition function ratio. This you can say this is a constant. But look over here, there are certain terms. What are they? Now, first is the temperature. So, how is the temperature going to affect? Look, this is very simple. If we increase the temperature, more and more ion family will increase, right? That means if the temperature is being increased, this will be going higher. So Ni plus 1 is proportional to temperature. More temperature means more energy, more ionization, right? Next, say temperature is kept fixed, and let me now increase the electronic density by putting a gap over here. Now I am putting in more and more electrons into the system. What will happen? More and more electron putting into the system will mean that the electron will have a chance of being recombined with the ions. So number of ions will decrease due to more and more recombination. So this means this Ni plus 1 will be inversely proportional to Ne. Because this increasing means more and more recombination. So these are two very interesting, you can say, takeaways from Saha equation.
Sir, in I plus 1 any mode radiation
any number of electrons, electron per unit volume. If I inject in electrons, then any inside this chamber, inside this box will increase. More electrons are there, so there will be more chance to getting recombined with the ions and all that. Okay, fine. Next question. Look at my hand. Right? Look at my hand. Tell me, in the space above my hand, are there atoms or ions? Or molecules? Molecules and atoms. Right? Question. Why are there no atoms in the space above my hand? Or even in this room? Why are there no ions? Tell me. Answer lies over there. Hint. The temperature is very small. If you do the calculation, okay, you will be amazed to find this ratio. It's exceedingly small. So we don't have ions. Although we talk about them, we don't have here to look after them, right? This is very important. It's a very interesting application of Saha equation. So any questions? So basically we have talked about this extension of family, how it family extends as the temperature is increased. First we have atoms, then we have more and more variety of ions. Okay.
Sir, partition function is showing ki variation ni plus 100.
এই যে এখানে দেখো 2i plus 1 divided by ui. This is the partition function. This you don't have to, this is technical, but these are much more direct relationships. Now, next question. The question is like this. Suppose, again, consider this at a very high temperature. Okay. And the question is, sir, how many 35 chlorine ions, say 5 plus ions in fifth excited state are there with respect to 35 chlorine atom? Is this a valid question or not? Very valid question. To answer this, you have to combine both Saha and Boltzmann equation. Okay. This is a very interesting application of both Saha and Boltzmann equation, and in fact when this thing was applied for hydrogen and helium cases, this is how the experimental verification also came for Saha equation. This is one of the important experimental verifications. বুঝতে পারছো? I am not going to talk about this. This is quite tricky. I will show you the results later on. Okay. Right now, just concentrate on the physics. Sometimes students often tell me that we are getting হারিয়ে যাচ্ছি অঙ্কের ভেতরে. That's why I am telling you this. Remember, whenever you think about Saha equation and all that stuff, start thinking like this box, where the temperature is slowly being increased, and think about the consequences and how are you going to quantify the numbers. And only then you will understand the importance of both Boltzmann and Saha equations. ঠিক আছে? Any more questions?